Hello, fifth grade. We are going to start our engineering unit right now. I hope you all did well on your test over physics. But the first part of the engineering unit, and this is where we talk about work and simple machines and complex machines and how everything kind of works together. But we're going to start with describing and measuring work. Okay, and we would have observed how sleds and rollers reduce the effort needed to do work, but we're not going to be able to observe that. So I might see if I can find you a video that'll kind of show how that works. There is a slideshow with this, so that'll probably demonstrate a little better, but not quite the same as hands-on, but we'll have to make do for right now. Okay, so if you have your booklet, remember I posted it under classwork there. You'll see it says engineering booklet. You can print that out and highlight it just like we would in class, or you can just open it up and read along. Or if you have Adobe Acrobat, if you open it in that, there's actually a tool that you can highlight it in there too. Okay, so and it says investigating tools and machines, which is part of engineering. And if you have yours printed out, you can always write on the front where it says engineering. You can put your name so you can feel like an engineer. Okay, so engineering is the application of scientific concepts for practical purposes. Okay, so there's all different kinds of engineering. It takes engineers to build bridges. It takes engineers to build buildings. It takes engineers to put together computer equipment, all kinds of different types of engineering. Even, Earth Day was yesterday. There's engineers that study the environment and how we affect the environment, all that kind of stuff. Okay, so they take scientific concepts and they apply it to real life. Okay, so scientists who apply the science they've learned to practical applications are called engineers. All right, so today's lesson, we're going to learn how scientists define work. And I know a couple of you have jokingly said, you know what it means already. And like when we're doing homework and stuff, that might not technically be work if you're just reading because you're not physically doing something. So this is the scientific definition of work. Okay, so we're on paragraph 1 on page 3. And it says, work is the transfer of energy from one object to another in order to make the second object move. If the second object does not move, there has been no transfer of energy and no work has been done. The object being moved is called the load, and the force that acts on the load is called the effort. So the technical scientific definition of work means an object is going to be moved. Okay, so if you're not moving something, you're not doing work. Okay, so really reading is even work because you're moving your eyeballs to do it. So it is technically work, but just not really the scientific definition of work. So at the beginning of the first sentence, highlight the word work. Work in the first sentence. So if I push on a desk and it doesn't move, have I done work? No, I haven't. If there's no moving, there's no work. Okay, if I push or lift a book and it moves, have I done work? Yes, because the key is it has to move. Okay, so the object that's being moved is called the load. So at the beginning of the last sentence, highlight the word load. It's whatever object is moving. That's the load. And then the force that acts on it, if it's a push or a pull or whatever kind of force it is, that's the effort. Or it could be a non-contact force like we talked about, magnetism. A magnet can move an object too. It's doing work, but it's not touching. But the object it's moving is still the load, and the force that acts on the load is called the effort. So this end of the last sentence, highlight the word effort. Okay, and sometimes they call the load the resistance force, and sometimes the effort is called the effort force. Resistance force kind of sounds like a Star Wars term to me, but for our purposes, we're going to call it load and effort. Okay, and paragraph 2 is going to say how we measure the amount of work that is done. Okay, and so the new word we're going to use is the measurement of that is called a joule. Okay, not the vaping cigarettes, not to be confused with that, but a joule is how we measure the amount of work being done. This is a good kind of joule. Okay, so paragraph 2. The unit used to measure work is called the joule. The amount of work done is calculated by multiplying the amount of effort by the distance the load moves. Effort is measured in newtons and distance is measured in meters. So those are terms we already talked about. With newtons is the effort, that's the force, and then distance is in meters because it's the metric system. 1 joule of work is done when a force of 1 newton moves a load the distance of 1 meter. So when a force of 5 newtons moves a load 2 meters, 10 joules of work has been done. Okay, so it's the effort times the distance. Okay, how much force you're putting into it times how far it goes. Okay, so for every 1 newton and 1 meter of work is 1 joule, because 1 times 1 is 1. But if you take 5 newtons of force and you move it 2 meters, it's 10 joules of work, because you just multiply one times the other. So at the end of the first sentence, highlight the word joule. It's spelled Joule, not like the kind of jewels you wear either. Okay, so the joule, I know it looks kind of funny. It's because it's named after a person and it's his last name. It's the same for the English physicist James Prescott Joule. And Joule conducted early research into the relationship between energy and work. So, of course, he had a unit of measurement named after him. And the symbol for the word joule, you know how in newtons we just put a capital N, and of course Newton was after Isaac Newton. Joule is just a capital J. So when you're abbreviating it, you just write a capital J. Okay, so if you have yours printed out and you have a pencil, you can write a capital J above the word joule so you can remember how it's abbreviated. Okay, so the mathematical formula, like I said, it's a pretty easy one for this. It's just one thing times the other thing. So it's the formula for it is W equals F times D. Work equals force times distance. Okay. So if you have it printed out, you can write that formula next to paragraph 2 to help you remember how to calculate, because you will have to calculate some later on. So it's a good thing to have that mathematical formula written down. So it's W equals F times D. If you write that next to paragraph 2, and then you just remember force times distance equals work. Okay. Next. Okay, and then of course there would have been a demonstration. I would have calculated the amount of work done if I lifted a book 1 meter off the floor. So the tool to measure 1 meter, you could use a meter stick, you could use a tape measure. But if I moved it 1 meter, and then what would I use to measure the force in newtons would be a spring scale. Okay, so if I put a book on a spring scale, or I need something to hook it onto, you lift it up 1 meter, however high up that spring scale went, that would be your force, and then your meter is 1. Okay, so you calculate the two. So whatever number of newtons it is times 1 meter would equal your number of joules of work. Okay, should be a pretty easy one to figure out. So if I lifted it 2 meters, I have to take the number of newtons times 2. Okay, so if you look at the middle of page 3, it says using sleds and rollers to make work easier. Okay, so obviously not everything you can just pick up and move it. There's some loads that are much bigger than other loads and heavier and that kind of stuff. So that's where the simple machines and other kinds of objects to help you do the work come in. Okay, so paragraph 1, we talk about sleds and rollers. So this is like if you've ever used a dolly, it's got, wheels on it. I'm trying to think. There's all kinds of different sleds and roller type things out there. But basically, if you're putting something on a cart or something like that with wheels, it's going to make it easier to move. So in paragraph 1, it says sleds and rollers are used to move heavy loads. A sled is a flat platform attached to 2 long parallel wooden or metal runners. A sled is often used to move a load across snow or ice. Okay, so obviously the sleds that we think of, you use them on snow. So you don't have to have wheels if you're moving along snow. It can also be used to move a load across uneven surfaces. Rollers are a group of cylinders that are placed parallel to one another under a load being moved. As the load is pushed or pulled, the rollers beneath the load turn. Rollers work best when moving a load across a smooth surface. So of course, if you've ever tried to, like we have rolling trash cans that we take out every week. When we roll them across the rocks or across the grass, it's a lot harder to move them than when you roll them across the cement. That it's this nice smooth surface once you get to the cement, so it's much easier to move then. Okay, and that would be a sled and roller basically. It's more just the roller part, but the sled part is just the flat surface. If you think of, I know sledding isn't as common in Texas, but if you've seen a sled, they're pretty flat because it needs to be flat in order to glide along smoothly. So at the beginning of the second sentence, highlight the word sled. Okay, so you move it across snow or ice, or to move objects across uneven surfaces. Okay, and then rollers are at the beginning of the fifth sentence. So you highlighted sled at the beginning of the second sentence. Then you highlight rollers at the beginning of the fifth sentence. And those are groups of cylinders that are placed parallel to one another, so they're going the same direction, like this. And they're used to move the load across a smooth surface. Okay, and then paragraph 2 is going to describe why sleds and rollers make it easier to move a load. So paragraph 2, sleds and rollers make it easier to move a load because they reduce the surface area in contact with the ground. When there's less surface area in contact with the ground, there's less friction opposing the effort. Sleds and rollers make it possible to use less effort to accomplish the same task. Okay, so there's less work being done because there's less friction happening. So if I were to take, for example, when I gathered all your textbooks up and everything, and I put them all in those bags, would it be easier for me to just carry all those loads of bags over to the parish office? Or do you think I put them on a cart so that I could just roll them over there? It makes it easier work to put them on the cart, because if I had them just laying flat in the bags, there's a lot more mass of the objects touching the ground than if they were on the cart. If they're on the cart, it's only the wheels that are touching the ground. So if there's less surface area touching the ground, the easier it's going to be to move. So that's why it's so much easier to move. Okay, that's what surface area is. That's just the area of the object touching the ground. And the surface part, we didn't really get into the surface area chapter in math, but basically it's the outside area. You've calculated the area of a square. You know, it's like length times width. Surface area is like if you have a cube and you're calculating this square plus this square plus this square plus this square, like all around the outside of it. Whereas volume is the inside of the cube. Surface area is along the outside. Okay? So since less surface area, that makes less friction. Remember, friction is working against objects, makes it harder to move. So I want you to highlight the sentence. When there is less surface area in contact with the ground, there's less friction opposing the effort. That's the second sentence. Highlight the whole thing. When there's less surface area in contact with the ground, there's less friction opposing the effort. Okay, and there's a slideshow that goes along with this, like I said, and I will post the username and the password again, but it's the Lesson 82 slideshow, and it's called Using Sleds and Rollers to Move a Load. So I will post that, and then you can go watch that And then we would have done an experiment with this to measure the amount of work being done. So basically what you would have done is measure the distance that you're going to drag something, and you would have used a spring scale to drag something a certain distance. So we were going to take like a book, hook it on a spring scale, drag it, and see how far it went, and then we would have measured the amount of work being done. Okay? But obviously we're not going to do that. You can always try that at home if you want to practice it. You probably don't have a spring scale at home, but you can still, I'm trying to think how you could do this. You wouldn't be able to measure the newtons as well, but you could measure something on a weighted scale just to see how heavy it is, and then try pulling it across. That would give you a vague idea of how it works. It wouldn't be exactly correct, but it'd give you kind of an idea of how much work is being done if you want to try that at home. Okay, so that's it for lesson 32. I'm going to post the lesson review 82 in Google Classroom, and you can go get that done after watching the slideshow.